Welcome, geometry students, to the homework help video, page 199. Let's go ahead and get started with going over today's homework. All right, numbers 1 through 4. We're going to use this picture right down here to help us answer questions 1 through 4. So here we go. Question number 1. Identify the legs of ABC. Well, guys, notice ABC is an isosceles triangle. We have the side here, congruent to the side here, and the congruent sides of an isosceles triangle are always called the legs. So your legs would be AB and AC. Okay? All right, moving on to number 2. Identify the base angles of DEF. Well, please notice in triangle DEF we have an isosceles triangle. This side here is congruent to this side here. Okay? So that means those two sides here are called the legs, as you guys know. So this side here is called the base. So if DF is called the base, which it is, then this angle here, angle D, and this angle here, angle F, are at the ends of the base. So those two angles there are called our base angles. So your base angles, oh, I'm sorry, it didn't ask for the base angles, it asked for the base. So the base of DEF is DF. This is the base right here. This is the base right here. Okay? All right, now on to number 3. Identify the base angles. Okay. We already said that ABC, in triangle ABC, this is your leg and this is your leg here, so this must be your base right here. So if that's your base right there, then B would be a base angle and C would be a base angle. So your base angles are angles B and C, and are they congruent? Yes, of course, because remember, in a triangle, when two sides are congruent, their opposite sides are also congruent. Okay? So, yes, they're congruent, angles B and C. All right, number 4. Which triangle is an obtuse isosceles triangle? Now, we understand, I hope we do, both of these are isosceles triangles, okay? Because both of these triangles have two congruent sides. However, this angle here, and this angle here, obviously, are all acute angles. So ABC is called an acute isosceles, but this angle, this triangle here, has an obtuse angle right here. Obviously, that angle right there is larger than 90. So this triangle here is called an obtuse isosceles triangle because we have one obtuse angle. So which triangle is obtuse isosceles? Triangle DEF. Okay, and why? Because angle E is obtuse. All right, moving on to numbers 5 through 9. Identify the legs of PQR. Okay, well, here's triangle PQR. The legs are the non-hypotenuse sides, so QP and PR are your legs. Okay, moving on to number 6. Identify the hypotenuse of STU. Well, here's the triangle STU. Remember, students, to find the hypotenuse, you always go to the right angle, and the right angle always points to the hypotenuse. This is your hypotenuse, okay? UT. Okay, number 7. In triangle STU, which angle is opposite the hypotenuse? Okay. Well, here's triangle STU right here, okay? Here's the hypotenuse right here. Which angle is across from the hypotenuse? Well, it's angle S, the right angle, okay? Angle S. Number 7. In triangle number 8, state the theorem that verifies that this triangle here, called triangle 1, PQR, is congruent to triangle 2, triangle STU. Well, students, remember, when you have right triangles, all that you need to know to prove that the two triangles are congruent is the hypotenuse leg. Is it a postulate or a theorem? I forget, but either way, hypotenuse leg. Do you have a hypotenuse here congruent to a hypotenuse here? Yes. And do you have a leg here congruent to a leg here? Yes. Are they both right triangles? Yes. So it's the HL theorem. Okay, the HL theorem. Now that we've stated these two triangles are congruent, do we know that PR is congruent to SU? Well, let's check it, make sure, okay? PR, well, here's P and here's R. PR is congruent to SU. Well, here's S and here's U. Okay? It looks like they're corresponding sides to me. So if these two triangles are congruent, which they are, then are these two sides congruent? Yes. And what would the reason be? CPCTC. Remember, students, when two triangles are congruent, we can then state that all of their parts are also congruent, okay? So most definitely. All right, moving on to number 11. All right, numbers 11, 12, 13, and 14, we were told to find the missing angles. So let's think this through here, okay? We know we have an isosceles triangle, so we know this angle here is congruent to this angle here, because when two sides of a triangle are congruent, their opposite angles are congruent. So this angle here is congruent to this angle here because these two sides here are congruent. Now, having said that, let's take 180, and because all three of these angles are interior angles, so they have to add up to 180. Let's subtract out the 50 degrees, and we're left with 130. So these two angles have to add up to 130, and they're congruent. So divided by 2, each angle is 65 degrees. Okay? Both of those angles. Okay, moving on to number 12. Number 12. All right, here we go. Same thing again, students, identical. This side here is congruent to this side here. So if that's true, then the opposite angles are also congruent, okay? So we know if we take one, we know this angle here that we're looking for is congruent to this angle here that we're also looking for. So I can take 180 minus 40. That gives me 140. And then divide that by 2. And both of these angles are 70 degrees. And you can check your work by adding 70 plus 70 plus 40, and you will get 180. All right, number 13. All right, a little different, but still it's pretty much the same thing. Notice I have this side here congruent to this side here, so their opposite angles are congruent. Okay, so this angle here is congruent to this angle here. So if this angle right here is 70, which it is, then this angle right here must also be 70. Now to find this angle up here, just simply add these two together, and you'll get 140, and then subtract from 180, and you will get 40 degrees. So the two missing angles are 70 and 40. Okay? All right, number 14. Here we go. Well, pretty redundant, but the exact same thing again. This side here is congruent to the side here, so their opposite angles are congruent. Okay? So with that in mind, if this angle here is 50, then we know that this angle over here has to be 50. So there's one answer. And if you add these two together, you get 100. And subtract that from 180, and you will see this angle here has to be 80 degrees. Okay, so moving right along, not too difficult. All right, numbers 15, 16, and 17. Now, we're going to pull this picture back up for number 17 in a second, okay? But right now, I think it'd be a lot easier when we look at number 15 and they want us to do a proof. All of this fancy stuff with a mirror here and a person standing here, that's really distracting in the way, to be honest with you. So I'm just going to copy what we need to know. Okay, here's our triangle. I'll pull this picture back up later when we need it, okay? There we go. There we go. This is A, B, C, D. All right? There we go. Now, let's go ahead and look at what they want us to prove, okay? You're given angle CDB is congruent to ADB. So CDB, this angle here, is congruent to angle ADB, this angle here. All right? You're also told, look at this, that BD, this is all in your given here, students, okay? BD is perpendicular to AC, right? So if that's true, then I know I have a right angle here, and a right angle here too, for that matter. Okay? So, do you not see our plan of attack? It's really obvious. We have an angle. Let's go ahead and split these two triangles up. Over up here, I'm going to write them a little smaller. Here's one triangle. Here's the other triangle. I know that this angle here is congruent to this angle here. I know this angle here is congruent to this angle here. And look, they share this side. They share the same side, guys. So I know this side here is congruent to the side here. So I can definitely state that these two triangles are congruent by angle side angles congruent to angle side angle. So I've got a pretty good plan of attack here. Let's make a checklist, okay? Here's my checklist. My checklist is, and when I say a checklist, I mean things that we have to state in our proof. I'm going to go and put numbers here so it's easier, okay? We're going to have to state somewhere in our proof that angle 1 is congruent to angle 2. We're going to have to state somewhere in our proof that DB, that's the shared side, is congruent to DB. And then somewhere, let's call these angles 3 and 4. Somewhere in our proof, we're going to state that angle 3 is congruent to angle 4. Okay? We're going to have to do that. So I've got a checklist here. We have to make sure all of these things are done in our proof. So let's see how we do, okay? Statements, reasons. Number 1, okay, you list all your stuff out here, and that's your given, okay? Now, notice in your given, you stated angle CDB is congruent to triangle ADB. So you've written that really right here. And don't forget, those two angles are angles 1 and 2. So you just stated right here, angle 1 is congruent to angle 2. That's in your given right here. Okay, so I'm going to check that off. Now, next, why not state this next? It's really easy. Just state it real quick. DB is congruent to DB. And of course, the reason would be reflexive. Okay? Pretty simple. Now, I've only got one thing left to state, and that's angles 3 and 4 are congruent. Now let's go to our given. Our given says that this side here is perpendicular to this side here. Okay, right there. So I know I have perpendicular lines, so I can definitely state this. I can state that angles 3 and 4 are what? Right angles. How can I state that? Well, guys, we have a theorem or a postulate that states perpendicular lines form 4 right angles. So there's 2 of them right there. Now that you've stated angles 3 and 4 are right angles, what do we know about right angles, guys? Angle 3 is congruent to angle 4. And the reason would be, and we've learned this, all right angles are what? Congruent. So you did it. You stated all of your stuff. So now we can easily state triangle ABD is congruent to triangle CBD. And what would the reason be? Guys, angle, side, angle. Angle, side, angle. Don't forget the 5 ways we've learned to prove that triangles are congruent, okay? Here they are. Side, side, side. Side, angle, side. Angle, angle, side. Angle, side, angle. Then a new one we recently learned is hypotenuse, leg, okay? Hypotenuse, leg. So, and this one here only works on right triangles. Okay, so there's the proof. Not too difficult, okay? All right, let's continue on to number 16. Okay, students, let's take a look now at number 16. Now, number 16 is really pretty easy. Think about it. It says, use your result from 15 to verify that this big triangle right here is isosceles, okay? So now think about it. For this triangle here to be isosceles, all that we have to have are 2 congruent sides. Well, students, we just stated that this triangle here is congruent to this triangle here. And remember, guys, once you state that 2 triangles are congruent, all of their parts are congruent. So look at this. We stated it right down here. In order for this to be an isosceles triangle, we need AD to be congruent to DC, do we not? Look right here. Here's AD, and here's DC. So we definitely know that this side here is congruent to this side here. So there, that's good enough. We just verified it, okay? AD is congruent to CD. Okay? And then very quickly, number 17. Number 17 is interesting, okay? Does approaching the mirror have any effect on the amount of reflection the person sees? In other words, do you see more of your body as you get closer or further away? And you might think the answer is yes, but the answer is actually no. And here's the reason why for number 17. I'm not going to write all this down for you, but here's the reason for number 17. If the person moves closer to the mirror, angle A, well, let's get the picture back up here again, okay? Let's get this picture back up here real quick. There we go. All right, now look at this. Here's the mirror right here, okay? Here's the mirror. Here's angle ADB right here, okay? No, sorry, that's not. Here's angle ADB right here, okay? Now watch this carefully. No, if the person moves closer to the mirror, angle ADB, think about it, will increase. Okay, as you get closer, it'll get smaller. And so will angle BDC, which is this angle here. So the entire body will still be reflected the same way, because these angles here will stay congruent because they will both shrink at the same time or at the same rate, okay? So I hope that makes sense, but that's the answer to number 17, okay? All right, let's move on to number 18. Okay, students, let's move on to numbers 18 and 19. Now, the directions for 18 and 19 state they want you to decide whether or not you're given enough information to prove or to state that these two triangles here are congruent, okay? So let's take a look at these. Notice for number 18 we have angle, 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 congruent to angle, angle, angle. That's all that we know, okay? So students, right off the bat, we know right away that we do not have enough information. There's no way, because you cannot prove two triangles to be congruent just simply by having three angles of one triangle congruent to three angles of another, okay? That's just not possible, okay? And the reason is you could have a real small 60, 60, 60, 60, 60, 60 triangle and then a real big 60, 60, 60 triangle, and they're not going to be congruent, okay? Their angles will be congruent, but the two triangles will not be congruent, okay? So that's number 18. All right, moving on to number 19. Now, number 19, this is really interesting, so please watch, okay? Watch the thought process I go through, okay? Watch this carefully. Now look, I know I have three congruent angles, thus I have an equiangular triangle. And we've learned that when you have an equiangular triangle, you also have an equilateral triangle. So I know this side here is congruent to this side here, is congruent to this side here. They're all the same. Now look, I know this side here is congruent to this side here. In fact, I have all three sides here of this triangle congruent to all three sides of this triangle. So yes, you see how I did that? Yes, I know for sure these two triangles are congruent because side, 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 three sides of one triangle are congruent to three sides of another triangle. So most definitely we know that by side, 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 okay? All right, moving on to number 25. Okay, proving this theorem. Now remember, anytime you prove a theorem, you gotta draw your picture first. So if two angles of a triangle are congruent, then the sides opposite them are congruent. So let's go ahead and draw our picture. Here's our picture. Okay, there we go. And let's just call this triangle ABC, just like we usually do. Okay, there we go. And if two angles are congruent, so we're going to call this angle 1 congruent, angle 2 congruent, okay? So there we go. Now your if part is your given. So we are given two angles of a triangle are congruent. So we're given angle 1 is congruent to angle 2. Okay, now your then part is your proof part. So I'm going to prove that the sides opposite them are congruent. So the side opposite A is BC, and the side opposite C is AB. So I'm going to prove that AB is congruent to CB. Okay, there we go. So let's put down a plan of attack. Now some of you might think, well, we proved the other theorem in our notes, so I'm going to draw this here so that it hits the midpoint, and that I know this side here is congruent to this side here. Well, that's not going to help, guys. Look what you have. You have side angle congruent to side angle. And guys, that's the one method you can't use, okay? So don't do that. We have to go with another idea here. Well, how about this idea? How about this? How about instead of drawing a line that hits the midpoint, how about if I draw a perpendicular line? I can do that. Remember, any two lines can be perpendicular. So I'm going to draw a line that comes straight down. Okay, and hits this line here, and it's perpendicular. Okay, I can do that definitely. Now remember, students, I'm just brainstorming, okay? Now if that's perpendicular, then I know I have a right angle here and I have a right angle here. Now look what I have. I have an angle and a side congruent to an angle and a side. So I can definitely state that this triangle here is congruent to this triangle here by angle side. And once I do that, I can then state that this side here is congruent to this side here by CPCTC, which is my goal. Okay, so there we go. Not too difficult. All right, so here we go. So let's go ahead and make a checklist, okay? I'm going to call these two angles here angles 3 and 4, okay? So somewhere in my proof, I've got to state that 1 is congruent to 2. Also, somewhere in my proof, I've got to state that angle 3 is congruent to angle 4. And then also, somewhere in my proof, let's go ahead and call this point D. I've got to state that BD is congruent to BD. Okay, there we go. So let's see what we have here. Here's my statements. Here's my reasons, okay? Now, number 1, I put my given, okay? There's my given. And so notice right away in my given I've stated this, so I can check that off my list. Check, okay? Now, let's go ahead and do this very quickly and get it over with. Let's go ahead and state that, hold on one second please, let's state that BD is congruent to BD, okay? And so that's going to be the reflexive property. Okay, check that off. Wrong one, sorry. There we go, check it off. Now, how about angles 3 and 4? Well, I haven't drawn my line yet, so I'm going to go ahead and draw my line. Draw BD perpendicular to AC. Now my reason would be, let's see, through any 2 points there exists a line, would be good enough. If you drew a line perpendicular, that's totally fine. I'm really not too worried about the reason you would put here for number 3. Okay, not that big of a deal to me. So we draw a line draw a line BD. Now that we've done that, we can state that look, we did it. We drew a line that's perpendicular. So if these two lines are perpendicular, then we can definitely state that angles 3 and 4 are what? Right angles. Okay? And we can state that because perpendicular lines form 4 right angles. Okay? And then we can state angle 3 is congruent to angle 4. And of course the reason would be right angles are congruent. Okay? So check that off. So students, we've listed everything in our checklist here. So we now have an angle and a side congruent to an angle and a side. So for step 6, I'm going to go ahead and state triangle ADB is congruent to. Now be sure and write your congruent statement here correctly. Okay, ADB is congruent to triangle CDB, and the reason would be, of course, angle side, like we've talked about. And now that I've stated that, I can definitely state that, look, AB is congruent to CB. There it is. So AB is congruent to a CB. And the reason would be CPCTC. Remember, students, as soon as you state that two triangles are congruent, you can then state that their parts are congruent, okay? So there we go, a 7-step proof, all right? Number 26. This one's really easy and really fast, okay, not too difficult, so here we go. D is the midpoint of BF, right here in the middle. So we know this side here is congruent to this side here. We know these two angles here are right angles, so we know they're congruent. And look, let's call this angle 1 and 2. They're congruent because they're vertical angles. So it's going to be really, really easy to use. Angle side is congruent to angle side, okay? It's going to be pretty easy to do. So we'll call this angle 1, we'll call this angle 2. Let's make a checklist here. Somewhere I've got to state that BD is congruent to DF. Somewhere I've got to state that angle C is congruent to angle E. And somewhere I've got to state that angle 1 is congruent to angle 2. Okay, so here we go. Number 1, list out your given. Okay, which is right here. There's your given. Okay, now in our given we know that D is the midpoint of BF. So students, if D is the midpoint, then I know that I can state if D is right in the middle of BF, then I know for sure I can state that BD is congruent to DF. And the reason would be definition of midpoint. Definition of midpoint. Okay? There we go. Check that off. Now, I'm told that angle BCD, which is angle C, and angle DEF, which is angle E, are right angles. So that's in my given. So here in my given, I've already stated that these two angles are right angles. So if I've already stated they're right angles, I can definitely state they're congruent. So angle C is congruent to angle E. And of course, my reason would be right angles are congruent, okay? Okay, now let's check that off. Now angles 1 and 2. Okay, well let's go ahead and state angles 1 and 2 are vertical angles. And the reason would be, of course, definition of vertical angles. Okay, so then I can state that angle 1 is congruent to angle 2 because we've learned that vertical angles are congruent. So check that off. So we're good. Okay, students, look what we have. We have angle angle side congruent to angle side. So I can definitely state, now watch your congruencies, state your congruency very carefully, okay? BCD is congruent to, well, if you put B first, be sure and put F first, and then next is C. So if C is next, then E has to come next, and then of course last is D, so D, okay? And that's it. Look, that's exactly what you're trying to prove, okay? So the reason was angle side, okay? So not too bad, okay? Let's continue on. All right, number 27. We're going to find the measure of angle A and B. Well, first of all, let's go through this very quickly, okay? First of all, I have a straight line here with a line coming off of it, okay? So this angle here and this angle here are linear pairs, which means they're supplementary. So if this angle here is 40, then this angle here is 140 degrees, okay? Now, notice this triangle here has two congruent sides, okay, here and here, which means their opposite angles are congruent, okay? Do you see that, okay? So if this is 140, subtract that from 180, you're left with 40. So these two angles here have to add up to 40. So this angle here would be 20, and this angle here would be 20. So A equals 20 degrees. Now, this is a right angle, got it? So that means this angle here with a dot and this angle here with a dot have to add up to 90. So if this angle here is 20, then this angle here would have to be 70 degrees. So now look at this triangle right here. Okay, 70 plus 40 is 110. So this angle here would have to be 70, because 70 plus 110 would be 180. So B equals 70 degrees. Okay, so let's go ahead and slide this off, and there we go. Okay, number 28. Now 28's interesting. If a lot of you jump to the conclusion that this angle here is 10 degrees, so this angle over here is 10 degrees, you're okay in doing that. I'm going to go a little slower and really break this down step by step, okay? First of all, look at the whole triangle right here. Look at this whole triangle, students, okay? There we go. Forget all of this stuff here. Just ignore that, okay? Just ignore all the inside stuff. Now look, this side here is congruent to this side here. In fact, I'm going to move this out of the way for a second. And this angle here is what? 55 degrees. See that? So, remember, if two sides of a triangle are congruent, their opposite angles are congruent. So if this is 55, then this angle over here has to be 55 also. So I'm going to go ahead and put 55 degrees here. Okay? Let's pull this back up. Okay, there we go. Now, let's think about this for a second. I know this triangle here, this is 10 degrees right here. So 10 plus 55 is 65. So this angle right here has to be 115 to give you a total of 180. Okay? Now, if this angle here is 115, notice right here I have a linear pair. Here and here. So if this angle here is 115, then this angle right here has to be 65. Okay, because 115 plus 65 is 180. Now this angle here is 90, so I'm going to go and put 90 degrees there, okay? 90 degrees. Now look at this triangle right here. I know I have an angle of 90 and an angle of 65. That's 155. So this little angle right here has to be 25 degrees. Okay? Now, this is 90, so I know this angle over here is 90 right here. Now look at this triangle right here. I'm going to copy this. I'm going to do it in black, I guess. Look at this triangle right here. Look at this and nothing else, okay? See that black triangle? See how this side here is congruent to this side here? That means their opposite angles have to be congruent, okay? So notice this angle right here is 65 degrees. So if that's true, then that means this angle over here also has to be 65, okay? So now I can very easily find angle B right here, because in this triangle right here, I've got a 90 and a 65. That means this angle up here for B must be 25, because 25 plus 65 plus 90 is 180. Now remember, this is a linear pair right here. So if this is 65, then this angle right here, A, must be 115. So there we go. Pretty tough problem, but that is the correct answer, okay? Okay, moving on to 29. Okay, well, angle B is the easiest to find, I believe. Let's take a look and see what they tell us here. Okay, here we go. First of all, students, I thought that we had parallel lines like this cut by a transversal. So if this is 100, this has to be 100. But nowhere are we given that we have parallel lines. Okay, nowhere. So let's do this instead. These two angles here are a linear pair. Okay, this angle and this angle. So with that in mind, if this is 100 degrees, and this has to be 80. Now, notice in this triangle here that this side here is congruent to this side here, so their opposite angles are congruent. So if this is 80, this angle here has to be 80. Now, if that's true, 80 plus 80 is 160. This angle has to be 20. And if that's true, vertical angles are congruent, so A has to be 20. Now, if A has to be 20, notice in this triangle here, I have this side here congruent to this side here, which means their opposite angles are congruent. So if this is 20 here, take 180 minus 20 is 160 and divide 160 in half. And this angle here has to be 80, and this angle here has to be 80. Thus, these two angles here form a linear pair, so B would have to be 100. Okay? So there we go. So B did end up being 100, but I have to make sure that my logic, my reasoning skills that I use is very solid, okay? All right, number 30, and we're finally finished. Number 30. Okay. L is parallel to M, so this line here is parallel to this line here. What is larger, x plus y or x plus z? Well, let's see. Okay, here we go. Well, we know these two equal 180, and we know that because whenever two parallel lines are cut by a transversal, their consecutive interior angles are supplementary. Okay, and these are consecutive interior angles. There we go. Now, we also know that vertical angles are congruent, correct? So, where the z is, I could also put a what? A y. So this group here also equals what? 180. So they are the same. There we go. Okay, think that over and let that sink in, okay? Students, I hope this homework help video has been a help to you. If you have any questions, don't hesitate to call or email.